Okay, so my project is on telescopes and astronomy. Okay, so what is astronomy? Astronomy is the study of everything in the universe beyond Earth's atmosphere. It's a natural science that studies celestial objects and phenomena. It uses mathematics, physics, and chemistry in order to explain their origins and evolutions about space. It includes planets, moons, stars, galaxies, and comets. So, what are telescopes? Telescopes are a part of astronomy. It helps humans see faraway things like planets and solar system in much closer perspective. A telescope is an optical instrument that uses lenses, curved mirrors, or a combination of both to observe distant objects. It uses emissions, absorption, and reflection, or reflection of electromagnetic radiation. So, optics related to telescopes. So, basically, how telescopes really work. Telescopes show faraway objects at focal length. This normally helps us calculate data about space. Telescopes all have curved mirrors, or not all, but most have curved mirrors to get light from and objects that you look at. The bigger the curve of the mirror and like the bigger the lens or the mirror, the more light that will enter the telescope, which means the more you could see. And the farther you can see. Okay, so telescopes have both convex and concave lenses. So basically, the concave lens is like the eyepiece of the telescope. So basically, right here where you look at, and then the convex lens actually serves as the objective. So the one over here that is away from the eyepiece, basically, and those work together and basically form a view that like your eye can't see, but it's like really close up. So yeah. All right. So what are convex and concave lenses though? Okay. So a convex lens is pretty much a lens that converges rays of light that are traveling parallel to its principal axis. So what does that mean? So basically, convex lens is this lens right here. So as light comes into the convex lens, it basically will converge all of the light rays, and right there, it'll actually make a focal point. So, what is a concave lens? So it's basically a thinner. It's thinner in the middle and wider on the outside, um, and it causes parallel rays to diverge. So what does that mean? So basically, you have rays of light that go into a concave lens right here, and basically instead of converging, they actually diverge away from each other. So yeah, basically to remember both of them, concave lens, it like caves in, so it would make a cave lens. Okay, so where are telescopes located? So basically, in the United States, there are about 11 major telescopes that let us see far beyond what our eyes could see. So most of these telescopes, they're located on the southwest of the United States. So basically, the reason why they're in the southwest of the United States is because because there's no light pollution. I mean, there's like rarely any light pollution there. Because when there's light pollution, like especially here in Rochester, if you look up into the sky at night, you probably won't see that many stars. You'll probably see a few, but barely any, because light is blocking the view. And when there's no light pollution, those telescopes could see more like stars, more planets, all those stuff. So yeah. All right. Even though most telescopes are on Earth, there are actually some in space that are even better because there's no atmosphere blocking the vision of the telescope. So basically, even if it's like a cloudy day, or if it's a rainy day, or if it's just daytime outside, like those telescopes in space, it doesn't really matter because they're in space. So there's nothing blocking the vision, and they could pretty much be used 24/7. So, locations. Okay, so the locations of some of these telescopes, so these are just some of them. I mean, major ones. They pretty much look like this. They're actually pretty big telescopes. They're not like ones that you'd buy at like on Amazon or something. So, yeah, I think the one in the background is actually a Hale telescope, but I'm not. Yeah, I think it's the Hale telescope right here. Okay, so companies that do astronomy. So there are a lot of jobs around the world that use telescopes, or companies around the world that use telescopes, and like do astronomy. They even have telescopes in space, as I mentioned. The biggest companies that do astronomy with telescopes so far is NASA, but SpaceX is also a new competitor in this field. But SpaceX was only founded in like 2002 by Elon Musk, so it's basically like not as big because NASA's been around longer and done more research. But SpaceX also did a bunch of stuff like pretty much uh, launch rockets up into space, and the fuel part of like the rocket. So this part right here, basically, they actually could land them now. So they keep reusing them instead of just wasting them. So jobs in astronomy. So there are actually a lot of jobs. So if you get your astronomy degree, you could basically be any of these plus way more. So you basically be a science teacher, a senior technical writer, a college professor, a planetarium director, a meteorologist, a research scientist, a climatologist. You could be, I'm not really sure what this one is, something engineer, and astronomer. So I think the guy in the background is actually a meteorologist, but I'm not too sure. Okay, so astronomy in Rochester. So I couldn't really find too many places in Rochester. I mean, I couldn't find actually any in Rochester that do astronomy. But I mean, the closest place I found that does astronomy is actually in New York City, and it's called NASA Goddard Institution of Space Studies. So basically, what they do is they research a broad study of global change like volcanic explosions and addressing natural and man made changes in our environment that occurs. So basically, like, probably when they mean by man made is probably like global warming and stuff. So other companies that do astronomy. So there are it's like there's NASA and SpaceX we already talked about. So SpaceX they built the Starlink satellite. Uh so there's also Swarm Tech. They created sandwich size lo-fi affordable satellites so companies can actually buy satellites without having to pay like millions or billions of dollars. So there's also space flight. There's Johns Hopkins APL. There's Capella Space. There's Space Tango. There's I don't know how to really pronounce that. And yeah, these are just some. So a OneWeb, a Space Out, Spacel. Yeah, okay. So basically, this is just like graph of like different like fields, like what like private space companies pretty much do. So the most important one is the 20% one. That's actually satellite launching. I'll explain that in the next slide why it's pretty important. But there's also satellite internet. So of course everyone needs internet. So that's a big thing that they spend their money on. Uh, there's also manufacturing. That's like I think making the stuff that go to space, but I'm not too sure. Yeah, that's probably what it means. There's also like a bunch of other stuff right here. So like space tourism, like 2%. They don't. I haven't really heard of like anyone like going to space really. But, like I don't know though, but yeah, I guess it happens. So technologies with astronomy. So in astronomy, satellites are one of the most important things because personal computers, cell phones, and all other devices just all work with satellites basically in space. Because you pretty much you could call somebody, right? And like across the world, someone could answer and talk with you, and you guys could be like miles and miles away, like just all across the world. So this is just one example of how astronomy is a significant part in our daily lives. So history of the telescope. So basically, the idea of the telescope can be traced back to Roger Bacon and a series of Middle Eastern scientists, and these are some of them. And the first ever telescope was actually invented in the Netherlands in 1608. And the first person to ever use a telescope to look at space was actually Galileo. And that's pretty much it for my project. And have a nice day.